Assalamu alaikum, welcome everybody to Practical Numerical Methods for Scientists and Engineers. We are here still in Module 4, Roots of System Equation, and today we have new method, LU Factorization method. It depends on the upper and lower triangle of the matrix. So here in this method, the coefficient matrix A, as you know, it is a multiplication results of upper and lower. So upper matrix, upper triangle times lower triangle, they are together is A. So from you know that's A times X equal P. So we can substitute. This means upper times lower times X. So it's equal to B. If we suppose that the upper triangle matrix times X equal D, then we can say that L times D equal B. So we can then, if we already B is known and L we already calculated, so we can find D. Then after that, U times X equal D, as we said here. Then we can find X. So just to go quickly for the steps. So first we find the upper and lower matrices of A. Then we can find D. Okay, suppose that L U times X equal D. Then we can find X. So how we can use it? Let's here take this example. So in this example, we have three equations. So the first one is to find the upper and lower matrices of A. So this is the matrix, and this is the upper one, and this is the lower one. So as you can see, the upper one, we can find it by forward elimination, like we did in Gauss-Seidel. And here, this is the lower matrix. I will show you how to find it. So then, okay, we can find, as we said, we can compute for D, okay, because L times D equal B, and since we already know the D and we know the B, so we can find D. Then after that, since U times X equal D and D is known and U upper is known, so we can find X. So this is a brief how we can use LU factorization method. So let's take an example. So find the roots of this equation using LU factorization. So these are my matrix. So okay, just what I will do is to keep this, take it. So this is A3 minus 0.1 minus 0.2, all this matrix, okay. Then by forward elimination, it will be converted to upper matrix. So we first, you remember the consider this one as a pivot and this one as alone as manipulated equation. Then we convert it to 0, and then again this is to 0, and then we converted the second step. We converted this one as a pivot, and this one so we eliminated. So this is my upper. Then we got already the upper triangle matrix. So how to get the lower triangle matrix? It's not difficult, but still a little bit tricky. You can find it by that. So we consider this is a lower triangle. One, construct this one, right? In right 1 1 1, then L21, L31, L32. T1 because this is a second layer, first column, third layer, or third rows, and first column, and third row, second column. So it triangle 1, then the upper is zeros, and then we have L21, L31. So as you know, L times U equal A, and you already got it or calculated from the previous step. Then we can start from, you can do by like this. So we can start by this row times first column. Okay, so what it should be, okay, so if you multiplied this rows from the matrix algebra, from the matrix, if you multiply this one times this one, so you should get this value. Okay, so now L21 times 3 plus 1 times 0, it will be 0, plus 0 times 0, so it will be 0, okay, equal 0.1. Then you can find L21 equal 0.33. So this one is, we got this one done. Okay, let's go for the second one. Let's multiply the same. If we multiplied this row by this row, okay, so we will get this value. Okay, so L31 times 3 plus L32 times 0 plus 0 times 1 should be equal, oh, this is mistake, should be equal 0.3. Okay, should be equal 0.3. Then, since we can find L31 equal 0.1, so now we could find L31 as well. Now, if we multiply the same row by the second column, we should get this one. Okay, so L33 times 3, L33, times minus 0.1 plus L32, we already know the L33 from the previous equation, so we can recall the value from the previous equation to be 0.1. Okay, so L32 times 7 plus 1 times 0 equal minus 0.2. So by doing this, we can find L33 equal minus 0.027. Then we can put these values here in this equation. So by this, we got to find U and L. Okay, so we have U and L. So what's the next step? We'll start by L. L times D equal B, and B already given in the example. So similarly, we can find all these. Okay, so write the values of the lower times D equal these values. So now we can get D equal D1 equals 7.85 and D2 equal minus 19.56 and D3 equals 70.74. How to find it? You can either find it by using a calculator. You can find by using calculator, okay, to solve it, or to find it directly by elimination. Okay, so you can find by either both of them easy. Calculator is much easier and faster, so you can find it to find D1, D2, and D3. Okay, now, okay, we already found it D. Okay, now go for upper. We said U times X equal D, and D is already calculated and U is known, so we can find X. Okay, now let's go for LU factorization method using Matlab. the method is very complicated, and it takes longer time using manual or manual calculation or by calculator, but interestingly, it's very quick and easy using Matlab codes. Why? Because we already have a function to find L and U quickly. So now we need to create a script. So for the method, we have A, input, insert the coefficient matrix, and B, insert the right hand vectors. Okay. Now we can find we want to find the L and U separately. So we create this brackets L and U equal LU of A. So then L and U already found. So then now to compute the D array, we D equal L by D. So L by D, because as you know we said here L times D equal B, then D equal B by L. So since this is a matrix, we can use a left hand divide, left hand slash. So D equal L left division by B. And similarly, we can find X equal U D. So once you do it, so insert the values, X will be computed directly to give me this value. So this is LU factorization method by Matlab. Thank you so much, and see you in another method. Assalamu alaikum.